So now that we've talked about the difference between displacement and the distance traveled, we want to extend that into the difference between speed and velocity. So speed is the rate at which an object is moving. It's how fast we're going. It is a scalar quantity, which means that direction doesn't matter. And you find it by taking the distance that you travel, the total distance, and you divide it by the time. So for example, you have a car that drives 100 meters in 5 seconds. What is the car's average speed? Well, in this problem, we know that the distance is 100 meters and the time is 5 seconds. And we know that speed is found by taking the distance that you travel divided by the time. So this is a pretty simple one where you're just going to take that 100 meters, divide it by 5 seconds, and find a speed of 20 meters per second. Now, what if we have a rocket that is traveling 110 meters per second? How long does it take the rocket to travel 3,300 meters? So when we're talking about how long, we're talking about time. So we know the distance and we know the speed. So what we have to do is we have to take that equation and we have to rearrange it. All right, so time is in the denominator. So we're going to multiply on both sides and get it out of the denominator. And then we'll have to divide by speed to get time by itself. So time is going to be equal to the distance divided by the speed. So we went 3,300 meters and we were traveling at a speed of 110 meters per second. So that's going to take us 30 seconds to travel that distance. Now, what if we have a race car traveling at 85 meters per second? How far does the car travel in 30 seconds? So we know time, and we know speed, and we know that speed is distance divided by time, and this time we're trying to find the distance. So to get distance by itself, we're going to take our speed, we're going to multiply it by time, and just plug in our numbers. 85 times 30 is going to be 2,550 meters. Now, velocity is a little bit different. So a lot of times you're going to hear it called speed with direction. And that's kind of a good definition as long as your object is only going in a straight line. Right? If we change direction at all, if we make a turn or anything else, then we can't really use that definition. So remember, velocity is a vector quantity. We do have to include direction with it. But technically what we do is we take the displacement divided by the time. So velocity is going to be equal to our change in position, which is displacement, divided by time. So let's go back to our ant on our ruler. Our ant is going to start at 0 centimeters, and he's going to start moving, and he's going to go over here to 5 centimeters, and then he's going to turn around and he's going to come back to 3. And that's going to take him 5 seconds. So what is his total distance that he traveled? All right, so if he went to 5 and he came back to 3, he went 5 centimeters and then 2 centimeters. So the total distance that he traveled was 7 centimeters. So what is his speed? Well, he traveled 7 centimeters in 5 seconds. So 7 divided by 5 is going to be 1.4 centimeters per second. Now, what is his displacement? Okay, remember, displacement is how far away you are from where you started. So he ends up back over here at 3 centimeters. So even though he traveled 7 total centimeters, he's only 3 centimeters away from where he ended. We don't really care what happens in between. We're just looking at that end point. So his displacement is positive 3 centimeters. So what is his velocity? So velocity is going to be displacement divided by time. So we're going to take that positive 3 centimeters, we're going to divide by 5 seconds, and that's going to give us positive 0.6 centimeters per second. So say we have a student traveling 11 meters north and then turns around and travels 25 meters south. If the total time of travel is 12 seconds, find the student's average speed. All right, so we're going to go 11 meters to the north, and we're going to come 25 meters to the south. So the total distance traveled is those two things added together. So we're going to have 36 meters as our total distance traveled. It's going to take us 12 seconds to do that. Speed is distance divided by time. So 36 divided by 12 is going to give us 3 meters per second. Now what is his velocity? Okay, so the time stays the same. And what we know is that velocity is the displacement divided by time. So he went 11 meters to the north, which would be a positive. And then he came back 25 meters to the south, which would be a negative vector. So remember, those vectors are in opposite directions, so we're going to subtract them. So our displacement is going to be that positive 11 meters minus 25 meters to give us a displacement of negative 14 meters. So what that means is, even though he went north and came back south, he ends up 14 meters south of where he started. So we're going to take that 14 meters and divide by 12 seconds, and we're going to have a negative 1.2 meters per second as our velocity. Now here's a fun one. How long does it take a car traveling at 45 kilometers per hour to travel 100 meters? Now this one's kind of tricky because our speed is given as 45 kilometers per hour, which is pretty typical when you're talking about a car. And we are given the distance as 100 meters. Now, in order to calculate with those two numbers, we have to convert the kilometers to meters or the meters to kilometers. It doesn't really matter which one, you'll get the same answer. So we're going to take our distance. There are 1,000 kilometers or 1,000 meters in 1 kilometer. So to convert 100 meters to kilometers, we're going to divide by 1,000. So instead of saying that our distance is 100 meters, we're going to say it's 0.1 kilometers. So now that we have those units the same, we can set that up so that our speed is distance divided by time. And we're trying to find time, so we're going to rearrange that so time is by itself. Our distance is 0.1 kilometers, and our speed is 45 kilometers per hour. So it's going to take us 0.0022 hours to go that distance. Now, that's not a very convenient number, so we could report this as minutes. What we would do is we would multiply that by 60. That's still going to give us a decimal number, so we could multiply that by 3,600. Since there's 3,600 seconds in 1 hour, we could report it as 8 seconds. And that's a little bit easier to kind of understand. It's something you can relate to a little bit better.